This video is about graphing trigonometric functions with some transformations involved. So if we look at y equals a times sine of b x minus c plus d, we have the following four things showing up for a, b, c, and d. A is the vertical stretch, which is something that is not really any different than any other function that we've done all year. Uh, and likewise with D being a vertical shift or C being a horizontal shift. Now, one thing that you will notice in this chapter when we're dealing with periodic functions, we call horizontal shifts phase shifts in this chapter. It's just a shift of where our cycle starts. So it's like where the phase of our cycle starts. So there's just a slight vocabulary change, but it's still a horizontal shift. And then B represents a horizontal stretch, which in essence, for periodic functions or trig functions, changes the period. Now, we also could have put something like y equals a times cosine b x minus c plus d, or tangent, cotangent, secant, or cosecant. All of these things do the exact same thing to the basic function, but they end up shifting it in a variety of different ways. We're going to graph one cycle of 8 different trig functions that have transformations. The amplitude is typically the a value, so that's 2 in this case. The vertical shift is down 1. The period of this function is going to be easier to discern. And the phase shift, if we factor out the 2. So if I factor out the 2, what I see is that the period is related to the b value. If we remember this from last year, I take the typical period of sine, which is 2 pi, and I divide that by 2. So that gets me the period of pi. Then the phase shift is to the right, pi over 2, because if I factor out this 2, I can easily see it. The domain of all sine and cosine functions is negative infinity to infinity. Then the range of a typical sine function, as we see from this picture, is negative 1 to 1. But I'm doing a stretch of 2 and a downshift of 1. So that means my graph will go from negative 3 up to 1 if I multiply all the y values by 2 and then shift them down 1. So the range is going to be negative 3 to 1 with brackets inclusive. Then, if I'm graphing this, sine, as evidenced by the picture, which will show up on all of these slides, sine is looking something like this. Then I have to put 5 x value points on my graph. There's a phase shift of pi halves. So I start with pi over 2. And then if I want to figure out what do I add every time, I always add the period divided by 4. So that will get me each of these tick marks that I need to do. So the period is pi, in this case, divided by 4. So I'm going to add pi over 4. So I add pi fourths, and I get 3 pi fourths, 4 pi fourths, which is pi, 5 pi fourths, and 6 pi fourths, which is 3 pi halves. So then I look at the graph in its context. So here when I'm graphing them, I just graph the same thing and I change the numbers. Here's a graph of what it looks like if I actually see where it would look like, what it would look like on the coordinate plane with the origin over here. Cosine, notice this 2 is already factored out, so I'm going to try and do most of these problems a lot quicker. Amplitude is 1, vertical shift is up 3. Period in this problem, once again, 2 pi divided by b. So period of 2 pi normally divided by 2 gives me pi. Phase shift is to the left pi. Domain of all sine and cosines are negative infinity to infinity. And then the range of this function, notice that there's no change in amplitude, but it gets moved up 3. So my range is going to be 2 to 4 brackets. Then cosine looks something like this, as evidenced by the picture. Phase shift is to the left pi. And then if I want to figure out what I'm adding every time, I take the period and divide it by 4. So I add pi over 4 every time. So negative 3 pi over 4, negative 2 pi over 4, which is negative pi halves, negative pi fourths, and then 0. Also notice this length is pi, which is what we said it would be. Just like over here, this length is pi, which is what we said it would be. Problem 3. This is cosecant, so cosecant looks like sine, but it's the reciprocal. So I notice that this is a negative cosecant, so it's going to look like a negative sine graph, but with the reciprocals here. It's also going to have some asymptotes. So the amplitude, you can either write 2 or you can write not applicable. The reason why we would say 2 is because the distance from the midline to the top would be a distance of 2. So if I look at the vertical shift down 3, this would be at -1 and this would be at -5. But more technically, the amplitude is not applicable in anything other than a sine or a cosine problem, because notice that the graph actually goes all the way down to negative infinity and up to positive infinity. So I'd accept either one. The period in this case is the typical period because there's no b value, so that's 2 pi. The phase shift is to the right pi over 4. And so we'll get to domain and range in a second. But if I look at where I'm starting at pi fourths. Then I have to add period divided by 4 every time. So I'm adding pi over 2. So this would be 3 pi over 4, 5 pi over 4, 7 pi fourths, and 9 pi fourths. Notice that this whole length should be 2 pi, which it is. So that's what it says it was going to be. The domain of this function, there's an asymptote at pi over 4, 5 pi over 4, 9 pi over 4. So if I look at where the asymptotes would typically be in a cosecant graph, 0, pi, 2 pi. So my asymptotes are where I don't have domain where I have domain issues. So x is going to be not equal to 0, pi, 2 pi, and so on in a typical graph. So I would say x is not equal to pi times n, where n is an integer. So in this case, all I'm doing is shifting it to the right, pi over 4. So I would say x is not equal to pi n plus pi over 4. So I just take what my normal one is, and then I shift it over however much I have to shift it. Unless there's some sort of period change, then I would have to take that into account too. The range of this function is negative infinity to negative 5, union negative 1 to infinity. And again, let's look at this graph in its context where the origin is here. So that's kind of what the graph would look like. 3 secant, so we're going to have similar stuff. Amplitude, you could either write 3 or not applicable. Vertical shift is down 1, so I'll get that taken care of on my graph right now. Period, it's going to be easier if I factor out the 4. So my period is normally 2 pi, but then I divide it by b. So my period is pi halves. My phase shift is to the left, pi over 4. So I have negative pi over 4. And then if I figure out what I have to add every time, I take the period, which is pi over 2, and I divide that by 4. So I add pi over 8, or pi eighths, every time. So if I add pi eighths several times, this is what I get. This is a secant graph, which means it looks like cosecant, but it's the reciprocal. Or, I'm sorry, it looks like a cosine, but it's the reciprocal. So it's going to look like a cosine graph. And then I have asymptotes here. So my graph is going to look something like this. Kind of looking like my secant graph, except it's shifted and stretched and stuff. So if I look at my domain, the typical issues that I have are at pi over 2 and 3 pi over 2. But in this problem, it looks like what's happening is everything got shifted left pi over 4, and I also had a period change. So if I'm looking at what would be happening in this graph, it looks like there's going to be a problem every pi over 4, right? So if I look at the distance between my asymptotes, the asymptote distance is pi fourths. So my domain is going to be all x's not equal to pi over 4n, because every pi over 4 there's going to be a problem. And then I have to shift it left or right pi over 8, because that's where the asymptotes actually are. So notice, if I plug in 0, I get negative pi over 8. If I plug in 1, I get positive pi over 8, and so on. So it would actually meet with what I have. The range is going to be negative infinity to negative 4, union 2 to infinity. And I screwed up the brackets and parentheses on this. Sorry about that. Parentheses, bracket. Then you check the answer in this context, and there it is. Of course, these are periodic functions that go on forever, and we're only doing one period of them. So 3 tangent of 2x plus pi halves. Again, amplitude is 3 or not applicable. Vertical shift, none. Period. If I factor out the 2 to make things easier, the period is, the normal period of tangent is pi, remember, and then I divide it by b, so I get pi over 2. Phase shift is to the left, pi over 4. So my graph is going to look something like this. So there's tangent. And then I'm going to have asymptotes, certain spots. And then I want 5 x values. So if we figure out where these things are, I have a stretch of 3. Then my x values, if I move to the right pi over 2, that means that this pi over 2 is getting clearly moved to the right, so that's going to be 0. Then how much, or I'm sorry, I'm not moving that way. I'm moving to the left pi over 4. I can't read. So this is not going to be negative pi over 2, and it's not going to be 0. It's going to be negative pi over 2 minus pi over 4. So that's negative 3 pi over 4. Then my period's pi halves. And if I need to figure out what I need to add every time, I divide that by 4, so I get pi eighths. So what I'm going to do is I'm going to move right pi over 8. So that would be negative 5 pi over 8, negative 4 pi over 8, negative 3 pi over 8, and negative 2 pi over 8. So I end up with negative 3 pi fourths to negative pi fourths. That'll help me with my domain, because again, my issues appear to be happening every, from 3 pi over 4 to pi over 4 appears to be a length of pi over 2. So x is not every pi over 2 times some integer. And then I have to figure out how far to the left or right I can go. So minus 3 pi over 4 or minus pi over 4 or whatever. Then the range here is negative infinity to infinity, because there are no y value restrictions. And that's kind of what my graph looks like. 3 more. I have 3 cosecant of this thing. Now I'll factor out the pi. So amplitude is either 3 or not applicable, depending on how you feel comfortable doing it. Vertical shift is +1. Then the period is 2 pi divided by 2, because our b is pi, so the period is 2. Phase shift is to the left 1/6. Then we'll deal with the domain and range in a minute after we draw it, so it's probably easier to just draw it. So here's my sine graph. So cosecant is going to look something like this. I'm going to have some asymptotes. I had a phase shift left 1/6. My period is 2. I divide that by 4 to figure out how much I add every time. So I'm going to add 1/2. So that's like adding 3/6. So I have 2/6, which is 1/3. I add another 2/6, which would be 4/6. No, I add a half, sorry. 1/3 plus a half is 4. My gosh. Brain power, not good. Negative 1/6 plus 3/6 is 2/6. 2/6 plus 3/6 is 5/6. 8/6 and 11/6. So those are my points. Also notice that from negative 1/6 to 11/6 you get 2, which is what we wanted. Now the domain is going to be all x's that are not equal to. There's going to be an asymptote every 1, notice. So x not equal to n, because my interval between asymptotes is 1, so 1n, and then minus 1/6 would end up giving me an asymptote everywhere I need one. Then the range is going to be negative infinity to negative 2, union 4 to infinity. And notice my cosecant graph kind of looks the same. And here's what it looks like in context. 2 more. So here, this pi over 4 is already factored out, pi fourths. So amplitude 6. Notice that the 6 is to the side, but that doesn't mean that it's not the amplitude. Vertical shift is +2. That's here. Period is going to be 2 pi divided by pi fourths, which is 8. Phase shift is to the right 3. So 8 divided by 2 gives me, 8 divided by 4 gives me 2, which is what I have to add every time. So 3, 5, 7, 9, and 11. Cosine looks something like this. That's really terrible, but I'm drawing on a tablet, so it's kind of hard. I shifted up 2, and then the stretch is 6. So the domain is negative infinity to infinity, and the range is negative 4 to 8. That should be a bracket. And then that's kind of what my graph looks like. Negative 4 to 8 is the range, 3 to 11, and then of course it keeps going forever, and that's why the domain is negative infinity to infinity. Last one, we have a cotangent. Amplitude is 7 or not applicable. Vertical shift is down 6. I'm going to factor out this pi over 3. So I'm not going to write all this stuff just in the interest of time. Period here is 1 pi, because cotangent's period is pi, divided by pi thirds. So the period is 3. Phase shift is to the right 2. So cotangent graph looks like this. I'm going to move this a little bit so it doesn't look horrible. Apparently, you have to move all of them separately. The range is going to be negative infinity to infinity, like all cotangent and tangent graphs. The domain looks like I got shifted right 2, and then my period is 3, so it's going to end at 5.
And then if I do 3/4, because 3 divided by 4, period divided by 4, that's what I have to add every time. So that's 11/4, 14/4, 17/4, and then 20/4, which is 5. My vertical shift was down 6, and then amplitude is 7. So these points should be at 17/4 and 11/4, but my graph isn't so hot. Now the last thing is the domain, where my asymptotes. And my asymptotes are at 2 and 5 and so on. So x cannot be 3n because it's an interval of 3 and then plus 2. So if I plug in 0, I get 2. If I plug in 1, I get 5, and so on. And then there is an example of the graph, and the asymptotes are at 2 and 5, which I drew very poorly.